Evaluating the integral using the trapezoidal rule. The concept is almost the same as evaluating by using the rectangular method. However, in the trapezoidal rule, what you have is, instead of rectangles or the area under the curve being divided into rectangles, you have trapezoids. So you have this area, this upper triangle, being added to the rectangle, or altogether forming a trapezoid. So the formula, it will change a little bit, but this concept is almost the same. Instead of multiplying the step by one height, which is the first height, I need to get the area of this trapezoid, or we're going to add the area of rectangle at first, also with the area of the upper triangle. Now, the area of a triangle is base times height divided by 2, which is the base, of course, is the step. The height of this triangle is the height at A minus the height at x1. I want to get the absolute value, then multiplied by the step. So it is the step times the height, which is again the height at x1 minus the height at A, by absolute value, of course, because sometimes it might be negative, and divided by 2. So step times height of the triangle divided by 2, we add it to the area of the rectangle beneath it. Going back to code blocks, we already have the polynomial function that give us the value of the equation y having the form of y equal ax2 plus bx plus c at whatever point x. We're going to add the function for the integral that will use the trapezoidal method. Our own method won't be like the formula for the trapezoid, but instead the formula for the rectangle, which is a part of the trapezoid. Here's what I'm talking about. This rectangle plus the area of the triangle above it. So double, we will call it trap integral, double A, double B, and double C. Then the first boundary B1, second boundary B2, finally the step, which again will define the resolution or the accuracy of the result. We will start with x equal b1, the first boundary, double s is equal to 0, which will be the sum. It will keep adding until it adds all the areas, all the trapezoids, so to speak. While x less than b2 minus step, as we've seen before, what would be the area? S plus equal the area of rectangle, which is polyec, A, B, C, and X, times step, that is the area of the rectangle beneath, as we mentioned, at the first point, and this height times the width, or the step, plus the area of this triangle, which is, by the way, the height of this triangle is height at x1 minus height at A, times the step divided by 2, plus absolute value, in case it was negative, the higher value was the negative one, polyec, A, B, C, x minus poly A, B, C, x plus step, and that absolute value is the height times the step and divided by 2. Of course, we need to increment the x position by a step. Finally, return s. We will also use the same function over y equal x2 to compare the results, to compare the accuracy between the integral of y equal x2 using the rectangular method and the trapezoidal method. Double trap sum is equal to trap integral a equal 1 for y equal x2, and b and c are equal to 0. Boundaries are between 0 and 2. The step is 0.01. And printf sum or area using trapezoidal method between 0 and 2 is %f, and that float value is the trap sum. Let's run it, and this is the value. You see, it's not always the case that the trapezoidal method is more accurate than the rectangular method. It happens that the rectangular one was more accurate. However, it depends on the type of function. But if we reduce the step to 0.01, you would get a more accurate result, and you have a more accurate value.